we kind of talked about this yesterday. We're talking about graphs today. How can we tell whether a graph is a function or not? Actually, let me go back to yesterday. How can we tell whether this is a function or not?
It's got two numbers in the bridge.
No, that makes it a relation if it's got ordered pairs. Is this a function?
Yes, it is. It is.
It is because the x values are different.
Yeah.
Okay, do you guys remember what I said? How can you tell whether a graph is a function or not?
If there's a horizontal line not down the middle.
Okay, if it passes the vertical line test. If you can draw a vertical line everywhere and it only hits once, then yes, it is a function. Girls? So yes, this is a function.
Oh, so there's like two in a row, like two dots.
Yeah, so what is not a function? This is not a function. Okay, there might be a bunch of other dots over here. Because basically what this means is maybe this point is like 3, 1, and maybe this point is 3, 3. So that would not be a function. The 3 goes to two different things. Is this a function?
Yes, yes it is. Yes it is.
Yes. Passes the vertical line test.
But how do you know?
Is this a function?
No.
No. It fails the vertical line test. If it hits at 2 points, it doesn't work. If it hits anywhere at 2 points. And the domain meant, what did domain mean yesterday?
No.
X values, and the range meant Y values. Okay, so on number 1, it's just yes or no. Is that a function?
Yes.
Yes. Passes the vertical line test. Number 3, is that a function?
No.
No. At x equals -3 or x equals -1, it's going to fail the vertical line test a few times. Number 5, is that a function?
Yes.
Yes, passes the vertical line test. Okay, number 7, for each graphed relation, remember relation just means ordered pairs, state its domain and range and whether it's a function. So on number 7, let's start with the domain. What did domain mean again?
X values.
X values. So X values, remember, go left and right. Left and right. So let's start with the point farthest to the left. What is this? No, X is left and right. So let's start with the point farthest to the left. What is the X value of that point?
-4. No, yeah, -4.
-4. The leftmost point, the farthest to the left, is -4, -2, right? So the X value of that point is -4. That's part of the domain. So if you step to the right 1 step, there's 2 points there. What's the X value of those 2 points? -3. If you step to the right 2 steps, X equals -1 has a couple points. And then if you go
No steps.
right on the 1 step to the right, there's a point on the y-axis. What's the X value of this? 0. The range is the y values. The y values go from low to high, up and down. So let's start low. What's the lowest y value? -3. And then it steps up 1, so that's -2. And then if you step up 1, there's a couple on that line. -1, and what's the highest y value?
0.
Does that have to be in order?
No, but it'll make it easier to grade because they're probably going to put it in order. That's what the books do, but technically, no, there's not really. Okay, is number 7 a function?
No.
No. It fails the vertical line test. Number 9. So same thing, starting with the domain. So domain is x values, and x values go from left to right. So let's start all the way to the left. What's the lowest x value?
-4.
-4 again.
Well, you said domain was.
Domain is x values. X values go left and right. So that point on the very left is at -4, 1, right? So the x value is -4. That means 1 is going to be a y value. We'll come back to that later. So, and then if we take a couple steps to the right, what's the next x value? -1. And if we take one step to the right, what's next? 0. And if you keep taking steps, there's like an x value for each one. There's one at 0, there's one at 1, there's one at 2, all the way up to what?
4.
Does it go that high?
I meant 3.
No, you're right, it's 4.
Ah. Oh, no.
Okay, range is the y values. If you get confused, they're kind of in alphabetical order. You guys know how x comes before y, right?
Yup.
And d comes before r
Yep.
also, so it's kind of in order. So y values go from up and down. What's the lowest y value in number 9? 1. There's a bunch of points on y equals 1. And then it's, what's the next y value up? 2. Anything else?
Nor.
No. Okay, is number 9 a function? Does it pass the vertical line test?
Yes.
Yes.
Yup.
Alright, number 11. This is where things get trickier. Maybe I should do an example before I...
I just jumped in the number.
Let me do, before I do number 11, let me make up an example. Because probably just doing number 11 by itself won't be enough. So let's do something kind of like the book did, but maybe a little different. What do you think these open circles mean?
That they're not part of the solution for graph.
Yeah. So there's no means there's no point right there. Every point coming up to that is there, but not that point. So yeah, okay. That's good enough. It's kind of sloppy, but all right. So for the domain for this one, you definitely need to pay attention because this part confuses people. So we're talking about x values. So what is the lowest x value on this graph?
-4.
-4. That's how far left it goes. Okay. What's the biggest x value on this graph?
0.
No.
Oh, or
Negative
-2.
No,
No, +2.
+2 right here. This point is supposed to be at 2, 2. So it goes all the way 2 to the right. Now, are those the only points?
No.
No. Actually, there's an infinite number of points. These are not just point, point, point. These are solid lines. So that means there's infinite number of points that are filled in between these two.
So every point is filled in?
Every point between -4 and 2 is filled in. How could I write that the x values are everything between -4 and 2?
All real numbers.
This goes back to last chapter.
Are you serious?
Oh, actually.
All real numbers.
Okay, well, if they had arrows on the end of this, like that means it would go forever, that would be all real numbers, but it didn't.
Exactly.
But it's not.
That could look like an arrow.
No, like, are you
Okay, anyways, shh. This is how you say x is everything between -4 and 2.
Are you serious right now?
You sound like one.
Well,
Okay, the range, the range is a little bit trickier. What's the lowest y value on this graph? What's the lowest y value on this graph? -2. What's the biggest y value on the graph?
Negative.
+2. Okay, now is every point filled in between those? No. From here to here, there are no y values. So, but from here to here, all the y values are filled in, from here to here. So what's the next, after -2, what's the next lowest y value? -1. Are all the y values between -1 and 2 filled in?
No.
Yes. Like, for example, y equals 0.5, that would be about right there. Or y equals 1.5, that would be right there. All the y values between -1 and 2, going up and down, are filled in. So for the y values, it would look like that. -2 works, and everything between -1 and 2 works.
Is it always gonna be less than or equal to?
If you go from low to big, yes.
If it's like, if that arrow at negative, or that dot at -1 was open, would it be -1 is less than
Yes.
y?
Yeah, if this, she said if this was an open circle, I don't know if I can get rid of that. Just put a little dot out. Yeah, if this was an open circle, that means -1 would not be included in this, so you would just use -1 less than y less than or equal to 2. Alright, that was an example, yeah.
What is the line called in quadrant 3? Like
The
the,
line in quadrant 3.
I don't remember.
Horizontal line?
No, like from like 4 and then to the,
-4 to 0?
yeah, what was that called?
Horizontal line.
No, he had a certain name for it. It was
It's called a line.
Horizontal line.
go back in time.
Bro,
Not that hard, dude.
just
Whatever.
have,
Yeah.
Andrew Tate mentality, bro. Go back in time. Just do it. Get the flux capacitor.
Okay, now back to the assignment. Number 11. I don't know if I want to actually draw that.
Are you serious?
So on 11, let's start with the domain. The domain is x value, so how far left does it go on number 11?
2.
-2.
-2 on that.
-2.
-2.
Okay, how far right does it go?
Positive.
+2. Are all the x values between here and here filled in?
Yes.
Yes. So the x values are between -2 and 2, so it's
Yes, I'm smart. Sometimes.
you just jinx yourself. Okay, the range is y values, so that's down low to high. So what's the lowest y value on number 11? Is it -4?
Yes.
And +4.
And is all the y values between -4 and +4 filled in?
Yes.
Yes. So it looks kind of the
And
same.
if it wasn't, what would it be?
Well, you might have to do something like the example where you put like a comma.
Can you check my
So, for example, on number 10, what's the lowest y value?
Negative?
No.
2.
Or 1.
One.
No, y value. 1, what's the highest y value?
2.
Are all the y values filled in between there?
No.
No.
So it's just 1, comma 2 for the range. 12 is kind of like the example I did. Oh, yeah. Is number 11 a function?
No.
Does it pass the vertical line test? Yes, it does.
Wait, okay. Let me reiterate. What is the vertical line test again?
If you draw a vertical line, does it hit any point, any more than one point? Any vertical line that you draw on that graph, does it hit more than once?
Yeah. It does, and
No.
but wait.
No. So at the end of it, it's kind of starting to get vertical, but it's not quite. Any vertical line that you draw is
For one square.
no. There's not.
Yeah, no, yeah, it is.
It's getting closer and closer to vertical, but it's not vertical.
So it will never be vertical in that case?
No, not in that picture. Okay. 13. All right. 13 says represent each function as a set, this part's important. Represent each function as a set of ordered pairs and graph the function. Alright, 13 says, it says a lot of stuff. It says x comma y. That's not really important. It's just saying those are your two variables. Then it draws a line. This is just a separator line. And then it says y equals 3x. Okay, y equals 3x, this is the important part. In function notation, it would be written as f of x equals 3x. Remember talking about that yesterday?
Yes.
Y and f of x are kind of interchangeable. But they didn't really write it like that, so we'll just keep going here. Then it says x equals... What do you think this is telling us?
What x is equal to?
Okay, this is the domain. This is the x values we're going to use.
Yeah.
These are the x values we're supposed to use. So, I guess here's how I want you guys to do it. Let's do it like this. Make a little table with x and y. Guess what I'm going to put on the x side of the table?
The domain.
Yeah, those three numbers that they gave us.
Do
Guess
we
how?
have to put the x comma y at the very beginning?
Guess no. You don't have to copy the problem down. I was just rewriting it.
Oh, well.
This part you do need to have, by the way. This is the answer right here. So how am I going to find what y value goes right here?
X times 3. Or y times 3.
Okay,
Or x times
I'm going to put in the x value of -1.
times.
So right here, this is the function. This is where it's happening. So x becomes -1. So y equals 3 times -1,
Negative 3.
-3.
Oh, I remember this last year.
We did not do this. Fine.
Yes, we did.
You probably
Yes, we
did.
I don't remember that.
I don't remember this
I have
last
no
year.
Okay, it doesn't matter if you remember. You
Zero.
just,
0.
okay, if you plug in 0, what's 3 times 0? 0. If you plug in 1, what's 3 times 1?
3.
Okay,
So hard.
these three things, you can just leave it like that. But if you write it as ordered pairs, it would look like this.
You want
Do we have to do that?
I'm going to say no. The directions did say write it as ordered pairs.
Well,
If we were to graph the function, we would graph these, and we're going to in a little while. We would graph these 3 points.
it says yeah.
Oh, it does?
Yeah.
Oh, I thought it was 17.
No. Nope.
Okay.
Relax.
So get out your graph paper.
I don't know.
You guys do not know how to do that.
All right. Clayton, where is -1, -3 at?
It's like bottom left.
So tell me where to go from here.
1 over to the left and then down 2.
And where's 0, 0 at?
Center.
What was center called?
Origin.
Origin. And then where's 1, 3 at?
To the right and then up.
All right.
Wow.
So the shape, you guys notice, kind of looks like a line, right? Do you think we should draw in the line or not?
No.
No is correct, although later on we will have to, and I'll explain why. So we're not going to draw the line because only these 3 points are the answer. Only these 3 points are the answer, not all the points between it in the middle here, just these 3. All right, are we good on 13?
Wait.
Okay, 15. By the way, on 14, do you guys know what -1 squared is?
1 times negative 1 is
Okay.
1.
Well, you could use the calculator, but you might still get it wrong. On -1 squared, you have to square all of x, so you have to square the -2. So it's -1 times -1, which is 1. So you should get a +1 for that first thing on 14. All right, 15. Okay, 15, they did use function notation. Did you guys notice? They replace the y with f of x. It doesn't matter, you're doing the exact same thing.
F of X is
So
one,
f of
right?
x equals 2x plus 3.
Did you do 14 as you see this?
No.
Uh,
And then we're supposed to use x equals negative 2, 0, 1 half.
bruh. And bruh,
So-
you
Let's make the table again.
just scoot up.
Yeah.
It's not like she's tall enough.
Oh, shut up.
Alright,
You still are.
Let's not
You still
forget.
are short.
You still are shorties.
You're not tall.
I'm not short
You
enough.
should
Well,
have
I'm not
like-
making the
All right.
argument. You're not tall.
anyways. We're gonna be plugging in these.
This guy's
So-
only 4 foot, dude.
Yesterday, I talked about a way that you could write this. This is, if you want to plug in negative 2, that's like saying what's f of negative 2. But basically, we just got to put negative 2 right there. So what is 2 times negative 2
Negative 4
plus 3,
plus is negative 1.
negative 1? Okay, let's try 0. What's 2 times 0
0.
plus 3?
3.
3.
1 half. What's 2 times a half?
Something.
1.5.
It's like saying what's half of 2?
Oh, it's just
1.
1.
yeah.
Plus 3.
4.
Let's plug in 1. What's 2 times 1?
2.
Plus 3.
5.
Alright, so those are the points we're going to graph. What shape do you guys think this one will take?
Circle.
Guys, hush.
It's Easton.
Yep.
Alright. Who wants to own a graph? Paxton. Where's negative 2, negative 1 at? That means you're next, Lennox.
I wanted to be next. Cap's just getting in his head.
Okay, Paxton, where's 0, 3 at?
Right there.
Wow.
Use directions.
It's like,
Left 3, right 3, up 3, down 3.
so like this is the line. It's
Okay, if I'm starting here, which direction do I go?
up.
Up 3.
If this is line, it's like,
Alright, how do I get to 1 half 4?
You go to 1 half.
You go over 1 half,
Which way?
right, and then you go up 4.
And then 1, 5, right, 1, not 5. Okay, what shape did it make?
Square.
A line. Are we gonna fill it in?
No.
No, we are not.
I said a line.
Invisalign?
Okay, number 16, let me give you a hint, guys. On number 16, if you do it right, it will be a line.
Will they all be aligned?
Okay, number 14
Getting bored.
is not.
Oh.
What's different about 14?
It's not a line.
It's a curve.
It's special.
Okay, it's x, it says x squared.
The what?
X squared graphs make a parabola. We're gonna talk about more about this later
Did you
on.
say parabola?
Parabola.
Oh.
It's spelled parabola.
That sounds
Parabola.
I knew it was gonna be a little curve.
It's,
Like a
yeah.
smiley face.
What's, is that?
Okay, on 16, listen. On 16, when you go to plug in negative 2.5, if it says negative in front of the x already, what do you think is gonna come out?
Roll.
Okay, we're plugging in, the first thing they tell us to plug in on 16 is negative 2.5.
Yo.
So if you put that in for the x, you have negative 2.5. What would that be? If you plug it in for x, you have negative 2.5. What's that? positive 2.5. And then it says
Flying out everywhere.
minus 4. So what's positive 2.5 minus 4?
-3.
Yeah, what you said.
1.5.
Yeah, it's kind of like $2.50 minus $4. It'd be -1.5.
Oh, you got it right. Cool.
Wait, is this 17?
That was 16. Okay, why didn't I put positive 2.5 right here?
Because that's not the answer.
Because the negative is outside of the
Okay.
x in the problem.
I didn't plug in positive 2.5, I plugged in negative 2.5. That's what we put in. Doesn't matter that it became positive later, that's not what we plugged in. All right, on 17 and 18, it's kind of the same thing. The difference is they're not telling us what x values to use. If they do not tell you what x values to use,
That's what I was eating.
you just make up some x values to use. Listen, is that open?
It's not supposed to.
Of course you're not supposed to eat here, you know that.
What's this stick?
Oh, yes! Sister
Probably just get it out of the trash after class.
Okay.
Keep going.
Listen. So on 18, it just gives us y equals x squared and tells us to graph it.
I thought we're on 17.
I'm on 18.
Why would we be 17?
It's an odd.
Okay, because it does not tell us what x values to use, we have to make up some x values to figure out what the graph's going to look like.
2.
If they don't tell us what x values to use, the domain, the x values are unlimited, infinite, all real numbers. But for graphing purposes, we need to figure out what a few of the points will be on the graph. So I'm going to have you guys use, and I want you guys to use these for number 17 as well. From -2 to 2. This will give us 5 points that will help us graph.
Wait,
Okay.
how'd you find the -2, -4?
I just made them up.
Oh.
Why might I have chosen these?
They're in order.
Because they're close to the middle. They're close to 0. All right. If I plug in -2 for x, what comes out for y? What's -2 squared?
4. Positive 4.
Okay, -2 times -2. If you don't put parentheses around it, it would be wrong on the calculator. -2 times -2 is positive 4. Okay, if I plug in -1, what's -1 times -1? Positive 1. If I plug in 0, what's 0 squared?
0.
Negative.
If I plug in 1, what's 1 squared?
1.
Oh,
If I plug in 2, what's 2 squared?
2.
4. Sorry.
2 times 2 is 4.
Wait, can we just use like -1, 0, and 1?
No, use all 5. All right, so really don't need this bottom part.
That bottom part is feelings.
Like,
Well, the lowest y value is 0, so yeah, it's going to be going up. So where is -2, 4 at? Left 2, up 4. Where is -1, 1 at?
Right there. Up
Left
one,
one.
yeah, there.
Up 1.
And then like the other.
0,
part
0,
there. And then it's on like the
1,
other
1,
side, you know, like
right 1, up 1, and 2, 4.
It's on like the other side again, you know.
Yeah. So this graph is what you might call symmetrical. You guys know what symmetrical means?
Yes.
It's a
Means, yeah, the two sides are the same.
Mr. Jordan?
Okay. Am I going to fill in the picture?
Yes.
Yes. What's different about this?
It's
Yes.
Okay. The x values on this are unlimited, which means I could have used any x value. So I could have plugged in an infinite number of x values and like gotten all these points. So really everything should be filled in. Even the points that I didn't draw, like the gaps in here,
Do we have to do dots?
no. don't do dots.
Do line.
Okay, I am giving you a visual just to say that all these points that I didn't find are still part of the answer. I just didn't plug in all these weird x values over here. Like if I plug in x is 1.5, I get like 1.5, 2.25. Like,
Looks like a wishbone.
That hurts my brain.
okay, the graph, the graph should look like
All the way
this. It's a parabola.
With arrows.
Yeah.
Roman, you really.
Why are we drawing the arrows? Because it goes forever.
What do you think?
Why can't that be?
So on 17 and 18, the domain is unlimited. So your answer should be a solid line, not just a few dots.
You're not doing 17, right?
No. Show your work on 17. I will not just take the graph. Yeah.
Can we use the same numbers that we use on 18
For
for 17?
17, yeah, why don't you guys go ahead and use the same x values that I used
Oh,
for
you
18.
put 2.5.
Huh?
No, you didn't.
Oh, that, I was talking about 16 when I did the 2.5 thing.
Oh. Wait, we used the same ones. Why don't we just be the same thing?
Yeah,
Oh, wait.
14's pretty much the same thing. 17 is connected. Because they don't limit the domain, so there's an infinite number of points. So all the points should be filled in between the dots. They go forever. But on 13 through 16, it's just a few dots, because they only give you a few x values.